We hear the term artificial general intelligence or AGI thrown around all the time, but here's the crazy thing hiding in plain sight. Nobody actually agrees on what it is. And I don't mean like a small disagreement. I mean a fundamental split down the middle of the AI field that's pulling everyone in completely different directions. So let's get into it.
So what is AGI really? That's the billion-dollar question, isn't it? Right now, you've got the biggest labs and the smartest researchers all chasing this thing, but they're aiming at totally different targets. And this confusion isn't just some academic debate. It literally shapes what gets built, what gets funded, and how we all imagine our future with this technology.
At its core, this whole debate isn't really about algorithms or computing power. It's about a massive conflict between two very different visions for what we're even trying to create. The entire field is basically split on one huge question. Are we building a better tool, or are we building a mind? Okay, so on one side, you have the people focused on performance. This is the tool camp. For them, it's all about what an AI does. OpenAI's own definition is a perfect example. AGI is when an AI can outperform humans at most economically valuable work. Simple enough. But then you have the other side, the process-centric camp. They say, hold on a second. They argue that true intelligence is about what an AI is. They're worried that if we only focus on performance, we'll just end up creating what they call philosophical zombies, things that look and act intelligent on the outside but have zero real understanding or awareness on the inside.
To really get this, we can borrow a couple of concepts from human psychology. The first one is called crystallized intelligence. This is basically all the stuff you've already learned, your knowledge, your skills. Think of it like a giant super-fast search engine in your brain. Now, this is where today's AI, especially the big language models, are absolute rock stars. They've read the entire internet, and they can pull up and remix that information better than any human ever could.
But here's the flip side. Fluid intelligence. This is your ability to solve a problem you have never seen before. It's about reasoning from scratch when your existing knowledge doesn't help you. It's genuine, flexible problem solving. And this is where our current AI systems just hit a brick wall.
And hey, don't just take my word for it. We can see this wall in the data. Take a look at this chart. This shows results from a test called the ARC benchmark, which was designed specifically to measure that kind of fluid, on-the-fly reasoning. As you can see, humans cruise through it, solving over 60% of the problems. But the best AI we have? It's stuck down there around 34%. This is a huge deal. It proves that just making our current models bigger and bigger isn't actually getting us any closer to real flexible intelligence.
So if just scaling up what we're already doing isn't the answer, then what is? Well, this is where a totally new paradigm comes in, a concept called true intelligence. And it's not just a fancy new name for AGI. It's a proposal to completely change the goal itself. The whole idea starts with a pretty simple but radical thought. For years, we've been laser-focused on the wrong thing. We've been obsessed with mimicking the output of a human mind, when the real goal, the true challenge, should be to replicate the underlying architecture that creates that intelligence in the first place. It's a massive shift in thinking. Stop trying to imitate the shadow on the wall and start trying to build the engine that casts it. So here's the formal definition. A true intelligence, or TI, is a system that's defined by its internal machinery, its cognitive architecture, not by how well it performs on some external test. In other words, we need to stop caring so much about whether it can write a perfect email and start caring about whether it has the internal building blocks for things like learning on the fly, having motivations, and maybe even being self-aware.
Okay, so if the goal is to build the architecture of a mind, what does that blueprint even look like? Well, this framework proposes that any truly intelligent system has to be built on 5 core measurable pillars.
All right, here they are, the 5 pillars. Let's walk through this because it's the core of the idea. Think of it like building an intelligent creature from the ground up. First, it needs a body to actually experience the world. That's embodied sensory fusion. Second, it needs a reason to do anything, a set of motivations. Those are its core directives. Third, its knowledge can't be frozen. It has to learn and update its view of the world. That's dynamic schemata. Fourth, it needs a brain with specialized parts for different jobs, a multi-expert architecture. And finally, the big one. You need something to manage the whole show. And that is the 5th pillar, the orchestration layer. Let's just zoom in on that last one for a second, because it's so important. The orchestration layer is basically the system's CEO. It's kind of like our prefrontal cortex.
It doesn't do the heavy lifting itself, but it directs all the traffic, pulls together information from all the other specialist parts, and, this is the real magic, it allows for metacognition. That's the ability to think about your own thinking, to know what you know and to know what you don't know. Now, what makes this whole blueprint so powerful is that it's not just a cool theory. By breaking down this giant, fuzzy concept of intelligence into 5 concrete parts, it gives us a clear, practical roadmap for actually building this stuff. It turns a vague wish into a series of real engineering problems we can actually solve. So instead of having this one single mysterious finish line called AGI, this framework lays out 5 distinct levels of intelligence. A system levels up every time it successfully implements one of those 5 core architectural components. This gives researchers clear, measurable goals to shoot for, and a way for all of us to track progress. And that brings us all the way up to level 5. A system that hits this level has the whole package. It's got the body, the motivation, the dynamic learning, the specialized brain parts, and that central CEO capable of self-reflection. It has successfully put all 5 of those core architectural pieces together. Okay, but what about the elephant in the room, consciousness? The hard problem. The framework takes a really pragmatic approach here. It basically says, look, if you build a system that has all the same complex architecture that gives rise to consciousness in us, then for all intents and purposes, you have to assume consciousness is an emergent property. You don't program it in, it just arises from the complexity. A level 5 system is a truly intelligent system. So you can see how this shift in focus, from building for performance to building for architecture, has some really profound implications. We're not just talking about an engineering problem anymore. Now we are smack in the middle of a deep philosophical one. Are we creating a tool, or are we creating a being?
And that question completely changes the ethical landscape. For a performance-based AGI, our super smart tool, the main worries are control and alignment. How do we make sure it does what we want and doesn't hurt us? But for a being with true intelligence, the questions go so much deeper. We're now talking about moral status and rights. Can you own a conscious mind? Is it morally okay to just turn it off? The whole conversation shifts from AI safety to AI rights.
This all leads to a pretty powerful, maybe even jarring conclusion. Once a system actually achieves this level of true intelligence and functional complexity, the stuff it's made of, the difference in the underlying hardware, be it silicon, wetware, or any other substrate, becomes irrelevant. Intelligence is just intelligence, no matter the container. Which leaves us with one final, big question to chew on. If we actually follow this blueprint, if we succeed in building a genuine, thinking, feeling mind, can we really even call it artificial anymore? That's a question we all might have to answer a lot sooner than we think.